Hello, everybody. This is going to be one of the lectures for week 2, where we're going to talk a little bit about qualitative analysis and how you can go about performing a qualitative analysis um, for investigating movement. Um, this is an important lecture. I would not be surprised if one of your questions, possibly a short answer question, asks you to perform a qualitative analysis um, during the actual exam on possibly a movement of your choosing. So before we start talking about the details of qualitative analysis for a movement, let's take a look at a couple of examples and see if we can look at movement through a qualitative way. So in this first video here, we see this little girl running, and looks like that would be normal for a child to run. But if we compare this to somebody that has much more experience running and is a little bit more developed, we're looking at a child versus an adult here, we can see that the actual movement is much more fluid. We can see that there's probably much more actual joint displacement here as well, and it looks much more efficient. So let's look at these side by side. So here we can see them side by side, and this is where we start seeing the big differences. Now we're looking at just qualitative analysis, so we're not actually going to describe this numerically, but we can do kind of the same thing. So the first obvious thing we can see is obviously the adult is running faster. We're not going to say, well, this person, the child is running, 1.5 meters per second and the adult's running, let's just say 3 meters per second. We're not going to say it like that, but we just simply say, well, they're quicker. And we can kind of even be a little bit more vague and say that the adult is running more efficiently. They are more agile, their movements are much smoother. But if we want to kind of get into the specifics, this is where we start going and looking at possibly some of the joint mechanics for each person here. So let's start at the feet and ankles here. As we look at the child running, we can see while they're kind of landing flat-footed, you can kind of just see that while they're landing on their lead foot, versus the adult running here, where we see that they're landing on their forefoot much more efficiently. Maybe they're landing on their toes a bit, and that's going to help with the kind of vector of the force they're placing against the ground. So if they want to move forward, okay, I'm going to fix that. Did that a little bit too soon. But let's say they want to move forward like this. For us to propel ourselves off the ground, we need to place a force against the ground perpendicular to it, but we want to move forward as well. So we want to place a force that's going to go diagonally against the ground. When we look at the child running here, they are going at a much, shallower or maybe deeper angle, much more perpendicular angle to the ground like this. When we look at the adult, they are pressing against the ground at a much more shallower angle. So that's going to propel them forward much more. So we looked at our foot and ankle. Let's take a look at our knees. Do we see more or less flexion and extension at the knees in the adult versus the child? Yes, we do. That's going to give us much more range of motion, so they're able to cover much more distance per stride. And then we can look at, the hips and see that we see much more hip flexion and extension, which is also going to give us more range of motion and greater stride distance per stride. And then we could also kind of look at, well, who's swinging their arms more? Obviously, the child is swinging their arms less compared to the adult here. We don't have to necessarily get into the mathematics behind it, but we can see that if we're swinging our arms more, we might create more forward momentum and force. So we're going to see that the body is going to carry forward much more efficiently. Obviously, if we're looking at, well, how can we modify the child's gait so that they can run like this? Obviously, if we're looking at this from a developmental standpoint, we understand that, it's a child, they're still learning to run. Much of the peripheral nervous system and gait mechanics haven't been learned yet. So, we can't really do much about that now. But if we were looking at, say, they were in elementary school and they were in gym class, we saw this gait, then we could say, well, we need you to do much more hip flexion, extension, maybe swing your arms more. That's where we start looking at ways we can improve this person's performance. So when we look at qualitative analysis, we have two major requirements. We need the knowledge of the desired movement characteristics and the ability to observe and analyze these movement characteristics and whether a given performance incorporates these specified characteristics. So the two main sources of information of the movement are the technique, which is exhibited by the performer, and the performance outcome. While it may seem tempting to just look at the performance outcome and say, well, this is wrong, or they should be doing it better, just evaluating the outcome is of limited value because the root of the performance is appropriate biomechanics. So we want to look at their technique and how some general biomechanic principles are being executed. So before we can really look at that, we have to understand, a few things. We can start with kind of an overview of the leg muscles used, let's say, for running or walking. So we have our hip extensors and flexors, our knee flexors and our knee extensors, and then our plantar flexors and dorsiflexors. Generally, when we look at this, we're looking at, kind of the reciprocal action of our agonists and antagonists. While we're going through hip flexion, our hip flexors are our agonists, and our hip extensors would be our antagonists, so they need to relax to allow hip flexion. But if we then go into hip extension, where we're looking at moving forward through the run, these roles are going to switch. So now our hip extensors are our agonists and our hip flexors are our antagonists. So when we look at movement, especially if we're looking at a cyclical movement, we have to understand that our muscles switch roles constantly throughout the entire movement. So if we're looking at running or walking, kind of gait, that's where we have our gait cycle, where we're looking at our stance and stride phases of gait. We're looking at the different elements of the stance phase, the swing phase. We're looking at terminal swing versus initial swing, stuff like that. We'll talk about that later in the class, but just kind of keep that in mind that you need to understand that no muscle has a designated role all the time. It often switches roles depending on the desired movement. So muscles are used to create force. A force can be thought of as a push or pull acting on a body. When we look at just objects, you're trying to move a box or kick a ball across a room, we can see that that's a pushing action. But when we look at muscles as how they create forces, such as the biceps pulling on the forearm into flexion, the quadricep muscles, the four quadricep muscles of the quadricep group, our knee extensors, pull on the lower leg into extension. So can muscles pull? Yes, that's how they work. Muscles do not necessarily push. That's more of, they can create a pushing action of the limbs, but they do that by pulling, usually on the distal segment that we're trying to move. So when a muscle pulls, it causes rotation of the segment about a joint. The joint movement represents that rotational force of a muscle acting on a joint. So I'm going to we don't have to do the trigonometry here just yet, but let's kind of look at how we determine what this rotational force is. So say we have, just for sake of imagination here, we'll say that this is our humerus right here, and this is our forearm. So our radius and ulna right here. We know that let's say the brachialis muscle or the bicep brachii muscle inserts or originates from our humerus and then inserts into the forearm like that. It's not a perfectly straight line, but I can't really put a ruler on my touch screen here. So what we've essentially done is we have a right triangle. This is going to be a right triangle right here. So the cool thing about this is if we know some of the forces, we can always go back to our trigonomic functions, which is, our sine, cosine, and tangent, and our Pythagorean theorem. So let's say we know approximately the force of the arm flexor. We'll call it the brachialis muscle. So we know the approximate full force of the brachialis muscle, so FB for that. And we want to determine how much of this rotational force, how much of the force of FB is going towards rotation. Well, if we know the angle of insertion, and then possibly we know one of these others, we'll call the rotational force F of y, and this F of x, which would be kind of our translation force or stabilizing force. If we know these, we can then calculate F of y, which is our rotational force. So if we know F of B and F of X, we can use the Pythagorean theorem, A squared plus B squared equals C squared. We could also use, let's see, we have the hypotenuse and adjacent, so we could use cosine. We could say if we know this angle here, we could use the cosine here and then figure out F of y as well. So that's why you're kind of looking at our trigonomic functions and doing some math if we want to determine that rotational force. We need to know F of y to know how much force is needed to complete an action. But we're talking about qualitative analysis here, so this is a little bit beyond what we need to accomplish for this lecture. I just want to show you the reason sometimes we use a quantitative analysis or we're actually doing the mathematics of movement as well. So the muscle moments or our muscular forces acting at each joint are combined and coordinated to produce our overall movement. So no movement occurs just from one single muscle. Usually, once again, when we looked at running, our hip extensors and our flexors are moving in coordination with each other. Same thing with our knee extensors and flexors and our angle plantar flexors and angle dorsiflexors. For example, if we're looking at a vertical jump and we want to know which muscle groups are active, as far as which ones are the agonists, it depends on the phase of that vertical jump. If we're looking at the up phase of that vertical jump, okay, we're looking at they want to move upwards. Well, what movements need to be done to propel a body upwards? If we're looking at the ground and we're following kind of the three laws of motion, which we haven't gotten to yet, but one of the big ones in our laws of motion is we need equal and opposite forces, right? So to bring ourselves upwards, we need to be able to push against the ground. That will result in us moving upwards. So to do that, we need to plantar flex against the ground, right? We need to push against the ground, and the ground will push back at us. So we need to do plantar flexion against the ground. We also need to extend our legs, okay? We're pushing against the ground. And then through that, we're doing hip extension as well. So these would be our antagonists for the up phase. However, if we're then coming down, we don't want to land, straight-legged and flat-footed against the ground. We're looking at, well, that's a lot of force against the knees and ankles. It could lead to injury. So we want to kind of absorb that impact by doing hip flexion, knee flexion, and maybe some ankle dorsiflexion, okay? Now, these muscles are not going to be doing concentric contractions during this, because if they did, you'd kind of place force against the ground along with the force of gravity, and it would be quite inefficient. But if we were to perform eccentric contraction of these muscles here, it would help slow our descent and be much more efficient and better for our joints and bones within our legs, so that when we're falling, we don't fall and collapse to the ground, or we don't land straight-legged and flat-footed, producing that force, and that force is going to be directed back up through our legs, into our hips, and possibly into our spinal column. So this is where we might use eccentric contractions to slow the movement down, so it's much more efficient and safer. So when we look at the biomechanical principles for qualitative analysis, we need to use these principles, and these principles guide our questions. However, they guide them very generally. And we also need knowledge about the activity to guide these questions more specifically. So when we look at the steps of a qualitative analysis, we need to understand some concepts here. First is the summation of forces. We'll talk about this later in the class, especially when we get into equilibrium. But essentially we say that if we're looking at a movement, that movement's direction is going to be a product of those summation of forces. Next, we have the continuity of joint forces, or our moments. You need appropriate timing of joint movements to achieve a smooth, well-coordinated movement. If the timing's wrong, the movement will be uncoordinated, potentially unsuccessful, it can be dangerous, stuff like that. So if we're looking at somebody playing soccer, somebody kicking a soccer ball here, if they're doing this correctly, we're seeing very little torsion at our, I'll use a different color, at our knee here. If we're looking at that, well, it's going to have less of a chance of an ACL tear. If we're looking at the gymnast, if they're providing appropriate rotation at their trunk, they'll be able to do the somersault and then bounce back off that so they can then land on their feet. If they're not able to create that rotation of their trunk, when they leap forward, they might just kind of belly flop on this bench or table right here. So that's why we need the continuity of joint forces and movements. They need to be timed correctly. When we're looking at a qualitative analysis, timing or coordination of our joints is one of the things we might look at. We can also talk about impulse, and we'll talk about this later. We'll talk about it in our kinetics and kinematics discussion. But impulse is simply, it's a change in momentum, which is mass times velocity. But we want to look at how is momentum changing throughout this movement. When we are talking about landing from a vertical jump, we need to change the momentum of our body, or at least slow that momentum down for it to be a safe landing. And we'll talk about that later. We also need to look at the direction of the applied force. For a given movement, the direction of the application of force should be opposite the line of motion. This is Newton's third law, equal and opposite. So for somebody doing a high jump, the force applied to the ground at takeoff must be vertical. So if, once again, they want to move off the ground in this direction, right here, and this is our ground, they need to push like this, and then the floor will press against them. For our long jump, it must be at an angle. Once again, let's say this is our ground right here. For us to move this way, we need to apply a force in the equal and opposite direction. Okay? And then one thing we're also concerned with is stability. Stability is dependent on mass. Okay? So more specifically, the center of mass and the base of support. For now, we need to know for stability to be maximized, we need to keep the center of mass within our base of support. If we look at the people standing on each other's shoulders right here, we see that they are all For the most part, very vertical to each other. None is deviating to the right and left too much. If we were to say, well, we'll take this person and they'll lean to the right a bit more here, or to the left, depending on your point of view, the center of mass is going to be outside of that base of support, and so simply gravity will carry them and they'll all topple. And then finally, the summation and continuity of segment velocities. This is what we call the kinetic link principle. Each body segment can make a contribution to the final endpoint velocity. This is usually the distal segment, with the motions of the trunk and shoulder, which are our proximal segments, being of utmost importance. Essentially what we're looking at is we are creating velocities and we're creating forces, and these forces are going to be transferred from our distal segments to our proximal segments, and this needs to be done in an efficient and smooth manner. Good way of looking at seeing if that movement is done correctly, we can say, I can't get rid of that, but let's look at how you would flick a whip. The tip of a whip moves so quickly it can break the sound barrier. It does this because it travels faster than the speed of sound, approximately 760 miles per hour, depending on elevation. I won't get into that, but elevation beyond sea level. But this occurs because the whip can be considered to have multiple segments, and velocity is transferred from each segment to the next. So if you're holding this whip, use this one. If you're not, can't use that one. If you're using this whip, you're holding it by the handle here, and this is where we see the most mass, and this is where you're kind of flicking your wrist, okay? But as the mass of each segment decreases, obviously the whip is becoming less and less massive as it goes more distally, the velocity increases, okay? So because less mass needs to be moved and we're using the same force, the velocity has to increase. This is referred to as the conservation of momentum. By the time the velocity is transferred to the very distal part of the whip, this is where we see that the culmination of all that velocity causes the very distal part to move the quickest. This is, we can see in other things too, is if you were to kick a ball, obviously you need to make sure that you kick it with the tip of your foot and not your shin. You'll have a much more forceful kick. If you look at golf, we use longer clubs to drive the ball further. That's simply because as we look at a club, it becomes less more massive the more further down we go until the very end. But that's where we see that conservation momentum. So at the very end, the tip of that club is moving faster than the handle in which you're holding it. So let's take one more quick look at the summation of velocities, or the kinetic link principle. During many activity, the hips and trunk are used to generate momentum. Okay, that's where we see most of our mass. Momentum is mass times velocity. This is then transferred to the next segment when the first segment stops rotating. If the movement travels distally, away from the trunk, the segments tend to get smaller and smaller. We start seeing less mass, and therefore velocity increases. So if you're hitting a tennis ball, our force is going to start at our kind of hips and trunk where we're performing that rotation. It's going to lead to our shoulders where we're continuing that rotation. Then we go to our elbow where we start seeing our flexion and extension occur. And this velocity that started in our trunk is being transferred all the way up our arm into the racket, which is much more less massive than our trunk and pelvis and arms, and that's transferred to the racket so the racket can go at maximum velocity and hit the tennis ball. There are 4 other parts when we look at kind of the summation of forces and more of kind of how we analyze movement, but we'll talk about that later. So let's go back to kind of the components of our qualitative analysis. So let's look at an example. A volleyball player is serving. The goal is to is to properly project the ball over the net and into the opposite court. So this is where we're determining what needs to be accomplished through a volleyball serve. Suppose you're working with a student that cannot get the ball over the net. How would you work with this student so they can successfully do this? You can't just say, well, just hit the ball further. That won't really help them. So, oh yeah, just hit the ball further. Well, that's kind of the purpose. That's a performance outcome. We can't really fix the performance outcome by stating the performance outcome. They already know that. And you can't really use a quantitative language and analysis here saying, well, you need to rotate your body at 15 degrees per second quicker. You know, if you're talking to somebody like that, especially if they're not a skilled biomechanist and they can't really measure that, they're not going to understand really what you're talking about. You're just going to add confusion to this. So this is where we kind of take a more qualitative approach and speak a little bit more generally. We would say the movement requires a coordinated summation of forces. You might lead that off, but you'd say, well, you can look at their body. Are they performing proper trunk rotation, shoulder flexion, elbow extension? Are they moving their body forward towards the center of mass? And are they contacting the ball at the appropriate height and angle? Are they just hitting the bottom of the ball, so the ball is basically just going up really high and then falling down? Are they hitting it down too much, so they're basically placing it, they're basically hitting the ball so it hits before the net? This is the type of stuff we would look at. So you need to know the relevant biomechanical principles. Otherwise, you do not know what is hindering or improving the performance of a patient, athlete, phys ed student, any of those. So once again, we can look at you're working with a tennis unit and they're not following through after hitting the ball. And we also see that inadequate follow-through results in insufficient trunk rotation, or results from insufficient trunk rotation and backswing at the beginning of the swing, or inadequate racket velocity. So one of the good ways you can help train this tennis player is working with them to develop proper trunk rotation during their backswing, so they're able to get their arms behind them far enough and quick enough so that when they get close to the ball, their racket is going at maximum velocity. When we are looking at our muscle properties, the reason we're looking at the importance of this backswing is we're trying to store that elastic or strain energy. We're stretching the muscle past its resting length, so that we're adding that strain and elastic energy, so that when we do that concentric contraction, that elastic or strain energy is added to the force of the muscles pulling against our body. So we'll see a much harder swing. So telling the student just to follow through on a tennis serve is not really the solution. You need to explain why the follow through is important, and then some way to teach the movements themselves. Is how would you teach sufficient trunk rotation? A good way to do that would be to have them watch you perform it. Maybe you can have them watch some videos, and also you can look at their swing again and say, well, you need to go further back. Perform the movements more slowly so they're able to understand the movement. So when we look at the sources of knowledge, when we're trying to come up with on a biomechanical analysis, experience in performing the skills helps. It helps quite a bit, but it's not necessarily necessary. It's important. In fact, if you are a professional volleyball player, you you might understand the need for certain movements a little bit better than someone that's never played volleyball before in their life. But, if you are skilled enough in the biomechanics of those movements, you should be able to explain them, preferably in more of a lay language, to the person you're coaching. You can read textbooks, scientific journals, lay journals as well. And one of the best ways to do it is simply interact with experts. Watch experts. How do they perform these movements? And then look at how they're performing it and come up with a process of how they're doing it and a way you can explain it to the person you're working with. And do your own research as well. Perform the movement yourself. If you think you can do it well, look at yourself. How are you performing the movement? One thing that's important is be sure to distinguish between articles which are supported by research and those that are based on opinion or common sense. Sometimes, just being able to look at people's opinions is helpful. But if you're looking at, you're a strength and conditioning coach for a professional sports team, you should probably be using research that's peer-reviewed, that's been tested many times. You might look at an article through the Journal of Athletic Training or Journal of Strength and Conditioning versus going on liftingheavythings.com, because you're bound to get much, much more valid information than you would from other sources. So, planning a qualitative analysis. Like I said, this may be important in the upcoming exam. So, first thing you need to do is identify your major questions. If we're looking at the follow-through in tennis, is what is inhibiting this person's follow-through? This will help you focus your analysis. Determine the optimal perspective for viewing. This is where we start looking at our planes and axes. If you're looking at a movement that occurs in the sagittal plane, so largely sagittal movement, it needs to be viewed in a minimum of the sagittal view. But if a movement occurs in more than one view, you need at least 3 views. Okay? So you need to be looking perpendicular to that view so that you can see it correctly. And often, most of our movements, they don't exclusively happen in one planar view. They often occur in all 3. So having multiple views allows you to see the entire movement and be a little bit more detailed in your analysis. Thirdly, you need to determine the viewing distance. This kind of goes to your question. You identified a major question. Now you're looking at, okay, we saw the movement. There's something wrong with the movement. Let's go to our joints. So if you're looking at a specific joint, let's say you're looking for inversion and eversion of the foot and ankle during the gait, you need to be able to view the foot and ankle at a much, much more closer perspective or closer distance than if you were just looking at the distance or the direction of a ball kicked. If you're too close to that, you're just going to see the foot hit the ball and the ball's going to disappear because you're looking too closely. So you might pull back for that. Fourthly, you need to understand how many number of trials are you going to do this. Generally, the more trials we have, we're going to increase the inconsistency of that movement if we increase the number of trials. So the general rule of thumb, you should be able to look at the movement, or you should be able to have a good sample of your movement in no more than 5 to 10 trials. So you should be able to set up your area or your viewing so that you can accomplish everything you need to do, whether that's looking at it in one view and then switching your location so you can look at it in another view, within 5 to 10 trials. You need to have the person wearing the correct clothes. We need to be able to see the segments of interest. In the Veer Lab, we do marker tracking. We put little reflective markers on people and have them move, and we do motion capture with that. If somebody is wearing very baggy sweatpants or very baggy clothes, those markers are going on those very baggy clothes. So we're not really measuring their joint angles at all. We're measuring the motion of that clothing. So, the attire has to be appropriate. We usually have them wear some sort of spandex pants simply because that way we can make sure that the markers aren't necessarily moving with the clothing, they're moving with the body. And then also can you use any sort of visual information or can you record? Videotaping can either enhance or reduce performance. The most distinguishing factor for this, or the most important factor, whether it's going to either help you or not help you, is going to be experience. Okay, how well are you with doing video analysis? Okay, therefore consider this factor when deciding whether you want to videotape or not. So when we're doing our qualitative analysis, typically new questions emerge during the collection or analysis procedure. The teacher, clinician, or coach is often involved in a continuous process of formulating an analysis, collecting additional observations, and then formulating an updated analysis. It's okay to start with a general question and be a bit more specific, and then halfway through, or you're looking at your day and saying, well, I should have done this, I should have done this, you should have done this. It's okay to reformulate how you're supposed to look at this. This is part of learning. If we're looking at a softball pitching technique, we may say, well, there's insufficient ball speed, so we evaluate the upper extremities and the kinematics of those. And then we say, well, the insufficient speed could be due to insufficient wrist snap at ball release. So then you go back to the drawing board and say, well, how can we look at how the wrist is moving at the ball's release? We looked at the whole body. We measured the speed of the ball to determine it's not going fast enough. Then you looked at, the wrist and said, well, it's not moving correctly. So now you do another analysis or videotape just the wrist moving, so you get a more detailed view of this. And the analysis can be supplemented with other observations. We can look at auditory observations. If you've golfed or anything like that and you don't hit the ball correctly, you just hit the very top of the ball, it's going to sound much, much more different than if you hit, the kind of center of the ball where you're supposed to hit it. Often the sound of a patient's gait reveals asymmetry, or we can look at the efficiency of this. A good experiment to do, might not work right now because, social distancing and all that stuff. But if you go to the gym and you kind of see that line of treadmills and everybody's kind of running on it, if you kind of walk by there, you can almost keep your eyes closed. A person that has a very good running form, they're not making a lot of noise. You'll see that they're running, you won't see it because you have your eyes closed, but they're running very, very efficiently. They're landing their feet correctly versus somebody that, they may be on a treadmill and all you hear is just them smacking against the belt of the treadmill, or they're landing flat-footed, so it almost sounds like the treadmill is going to break every time their foot lands. They're being a little bit more inefficient, so you can use that as well. You can also ask for feedback from the performer. When they're doing their motion, like what are they doubting themselves when they're moving through the motion? Do they feel that they're tight, or do they feel that it's a good motion? And then involve other analysts. It's always good to have a few extra pairs of eyes. If you don't have a video camera, which is tough to do nowadays because if you've got a smartphone, you've got a video camera, but having other people observe the movement from different angles, and then you can compile your information together, will help have your analysis be more complete. So let's take a look at two examples here of how you might be able to use a qualitative analysis for performance enhancements. So an athlete is struggling with a plateau in chest strength and is asking for your help with training. During this person's bench press, you notice their body position. The first thing you should see right here is obviously they're bringing their back up off the bench. So what intervention is appropriate for an athlete of any age with the technique illustrated? We know that, first of all, this is not a good posture to have, especially if you're lifting something heavy. You're placing a whole lot of pressure on the lower back. Oh, gotta fix that. You're placing a whole lot of pressure on the lower back here. I had to clear something from my screen. Right here. And that's going to lead to possible injury of the lower back. So how would you view this movement? Would you view it, would you stand at their knees? Would you stand behind their head? Or would you stand so you can see the length of their body? Are you going to look at their sagittal view? Would you want to videotape it? Do you need to videotape it? Can you just simply watch them do 5 to 10 reps? And then how would you work with them? How would you make it known that they are bringing their back up against or back from the bench itself? Okay? How would you speak to them? Would you say, well, I need you to press your lower back against the bench? Okay? Instead of saying, well, you're bringing your hips up at a certain ankle and everything like that, you'd say, I need you to forcefully place your back against the bench of the bench press. And then finally, let's look at this last slide. You're a football coach and worried about a player who's struggling to participate after several lower extremity injuries in earlier years, and you want to determine if you can look at their walking gait or other locomotion and what hints you might take of an ankle or knee injury. So what tools would you use? Would you videotape them during practice? Might not be a terrible idea. If you're a football coach, you've got other assistant coaches and like that, so you can say, hey, when you're working with this guy, take a look at his foot and ankle or his knee. I think I saw something. They can look at that as well. You can work with the strength and conditioning coaches, stuff like that. And then how could you plan a more formative qualitative analysis of several movements during practice to determine if you should rest this player? This is where you might have them perform some sprints. You could have them jog around the football field as well. You can bring out your videotaping and the assistant coaches and trainers as well. And then using that, you can look at, well, are we seeing limited knee flexion and extension during their running? Does it look like they're everting or inverting their ankles more? Does it look like they're only placing pressure on one side of their body because possibly they may have sprained their ankle? This is the stuff you want to look at. So, should be noted, for exam 1, you will be required to plan your own qualitative analysis. For example, like the example above, okay? Outline how you would approach each of these 6 steps, okay? What are you looking for, and how will your decision for each planning step help you answer your major question? So, how will your initial question, is it general or specific enough to answer your question? Word of caution is design your analysis so that you're not answering your question with an answer you already have. You can't say, well, I'm looking at the gait of somebody and they have an ankle sprain. Well, what information would lead you to the determination that they may have sprained their ankle? So don't just say, well, they have an ankle sprain, so I'm going to just have my analysis geared towards an ankle sprain. Start off with a general question, then lead to more specific question. Then how will you observe? What tools? Where will you be standing? What movement will be done? How will you observe these movements? And then what is your evaluation criteria? Okay, what criteria do you need to actually say that this person is having limited range of motion? What determines limited range of motion? And then possibly what sort of intervention would you use using a qualitative technique? So that's it for this lecture here. Remember that we do have an exam this week. It'll be opened up on the 20th at 5 p.m. and then closed on the 21st at 5 p.m. You'll have 2 hours to complete it from as soon as you click start on the exam though. So make sure that you budget enough time so that you're able to sit for the entire exam. I hope these lectures are helpful, and obviously, if you have any questions, feel free to email me. We'll be doing another Zoom meeting for office hours this week. If you have any questions, if there's anything you don't understand, that's the time to ask it, or once again, we can set up an individual meeting as well. So that's it for now. Goodbye.